Oh, now you remember your name.
And welcome to the Desk of Lady Ada.
Hey everybody, and welcome to a lovely little evening here at the Desk of Lady Ada. I'm Lady Ada, this is my desk. And as always, I'm working on some hardware today. I sat down just a couple hours ago and started working a little bit more on the Circuit Playground board. This is the board that I did the hardware for over the last couple months or so. I've been working on, and I'm actually pretty much done with the hardware. I've tested everything. I feel like it's solid enough for release. And I sent out the boards for FCC and CE certification. So while I'm waiting for that, it's going to take a couple weeks for them to get back to make sure. I'm pretty confident it'll be fine, but you still got to wait until you get that certificate. While I'm waiting, I am working on thinking about how it's going to be used. So me and Tony DeCola, and he'll be streaming hopefully maybe tonight or tomorrow with some user code that he's working on. We're thinking, how are people going to use it? What's going to be like literally the way they plug it in and interface with it. And he's working on getting Fermata to work with Circuit Playground. So you plug it into USB, it shows up like a serial port, and then you have software that can send commands to light up the LEDs or read sensor data. And that way you can do all the programming on the computer side. But one of the things that we talked about when we were designing Circuit Playground is Tony DeCola made a really, really good point. He said, well, if you have a Chromebook, you can't really install drivers on it, so you can't really use an Arduino. It's challenging to do so. Now I think they've added some serial port access, but when we were first talking about this, it was not clear. There's people who won't be able to install any kind of driver. And the Windows 10, you don't need a serial port driver. It's built into the operating system, like thanks to Paul Stoffergen, who kind of complained to them until they fixed their bug, because it's a standard classification of USB device. And so we thought, so Tony and I thought, and we looked at how other microcontrollers do bootloading, and we thought, well, maybe we could have it show up like a hard disk. And so instead of having a USB serial device where kind of acting like an Arduino, an FTDI chip where you connect to it and you send serial data, you actually drag and drop a file onto it. It shows up as a hard drive. And I was like, I don't really know if that's possible. But then I was looking around the Lufa code base, and it turns out that there is some support for it. So I thought, maybe we'll go to the computer and I'll show kind of what I've looked at. And it is kind of interesting. So, I just Googled for Lufa mass storage. Lufa is the USB firmware stack for AVR that's written by, Dean Camera, don't know how you say it, but Dean wrote a really great library. We've donated to the cause because we really love the Lufa library, and he sent us a Lufa, like one of those sponges. And actually, back a couple of years ago in 2013, he actually designed a flash programming system for the USB core that uses mass storage. So, this removable drive here is actually the microcontroller when you plug it in, and there's a file called firmware.bin, and then you can drag the firmware on. And there's a little bit of a trade-off. First up, mass storage, it's the mass storage code is much larger than the bootloader size. So the bootloader, the protected bootloader size on the Atmega 32U4 is 4 megabytes. I wish it was 4 megabytes. It's 4 kilobytes. And the mass storage code is 6 kilobytes. So he actually has to do a little bit of a trick. And what he does, him and Paul Stoffergen both kind of came up with this idea together, is that they actually use a little bit of a user code space to put some of the code in user space, and basically the bootloader just does, it's best not to overwrite it. So it's not a protected bootloader area, so there is a little bit of a risk that it could get overwritten. So we know we have to consider this. It's like there's this ease of use, but it could get overwritten. So I really want to make sure this is tested before I put it in the hands of students, because there's nothing worse than bricking your device. So I downloaded the code, and it's actually on GitHub. So I grabbed the GitHub code, and the first thing you want to do is make a board driver. So in the boards directory under led.h, there is a little lf define macro area, and I created a new one for Circuit Playground. And I said, okay, it's going to be an AVR8. It's going to be called Circuit Playground. And that's where we'll define the LEDs and buttons and stuff. In this case, it's just LEDs. And then actually in here is the file. And I basically define, it has LEDs. It's the only thing that's really used in this bootloader. And I just define the LED is on pin 7, port C. And that is essentially digital 13. Hold on, let me find where digital 13. That's PC 7 is the mask, and port C and DDRC is the directional and port and pin register. Of course, this isn't written in Arduino. This is written in plain C, so you have to do register access. Once you define that, I did a little bit of changing around in in bootloaders and mass storage in the make file, and I'll upload this to our own GitHub repo if you guys want to just try this out. You set it to an Atmega 32U4, and the CPU is 8 megahertz. The flash is 30 for boot. And then what it's going to do is it's going to, Dean did a really nice job here. Like, it actually calculates like how much back into the firmware it has to go to put the rest of the bootloader in there. So you actually don't have to mess with anything else. So that was pretty easy. And then I did just make a small change to the virtual FAT. I just made it show up as Circuit Playground when you plug it in. So it actually says Circuit Play for the hard disk name. I also have to do the VAD and PAD, but I was going to do that later once I got everything else going. And you can see here, it's like, you can actually read the firmware off as well. It's called fat.bin and eeprom.bin. I might remove eeprom support because I don't know how necessary that is. You can do that in user space. Like, you can upload a program that will spit out the eeprom over the serial port. But I'm going to leave this in for now, and then I can always pare it down. It'll save me, maybe a half a K of space. And then one of the tricks that I did, because I was actually trying to figure out, how things worked in here, and there's not a lot of space in this bootloader. Like, I actually tried adding some debugging functions, and I quickly ran out of space because it's so constrained. So would it be great if I had JTAG emulation and debugging and SWD on this chip? Yes, but I don't. And I really wanted to get this going fast. So what I do is I have a really simple UART debugging. And you can do this in only a couple bytes of space. So if you're ever working on 8-bit AVR and you need some quick debugging, you can turn on the UART, and I just have some quick code to set up the UART. I have hardware UART access here. Set it to 9600 baud, set any baud rate you want, enable it, and then I send out single characters by just assigning it to UDR1, which is the UART data register. So it basically allows you to send a single character, which is minimal, but it helps a little bit. So for example, there's an LEDs function that gets called every overflow timer and toggles the LEDs. When it does that, I have it send the capital L. And that just lets me know my bootloader is still alive. I was actually debugging was the code up here. This code is is kind of the entry point. And what it does is it determines, if you should jump to an application. Like, for example, you don't want the bootloader to always enable when you plug in the USB device. You want it to only enable when there's no firmware loaded up, so the first time. And also, you want it to be able to force into the bootloader if something really messed up happened in the firmware. You want to be able to manually load the bootloader. And to do that, I basically made it so you hold down both of the buttons and you plug it in or you hit the reset button. But I wanted to debug if that was working, so I added a little thing here, invalid, print out the letter V, and if all other checks work out and it says jumped application, I print out the letter J. Just some basic debugging to kind of see what's going on. I would love to do step tracing, but I cannot. So that's what it is. So let's go to here. Let's see, I actually think that the latest debugging stuff I added might have made it too large. Let's see. So compile it, it's good, and we'll program it in. It creates a hex file over here, and let me see. Loofah, bootloaders, mass storage. Let's look at the hex file actually. So, sorry, I don't want hexd. I actually want to just drag this into here. So you can see that you can read Intel hex. It starts at address 6800 hex and continues on till 7FFF8. So really we don't have a lot of space left over here. It pretty much uses the entire, there's maybe like a couple bytes here. It looks like this is maybe a table, but really we're kind of out of space here. But it doesn't start at 7000, which is the normal address that you would use. It starts at 6800, which is address 26628. So, sorry, 26624. So that's as much data as you have left over. So, one of the trade-offs is you get mass storage, but if you're programming this, you can't fill up the 32 kilobytes, and you can't even fill up the 28 kilobytes you normally would if the bootloader fit in the bootloader section. Instead, you only have 26K. Well, maybe that's fine. Maybe for the projects we're doing, we're willing to sacrifice a little bit of flash space to have usability. Okay, so let's program this in, and then you can see on the, give it a second. Verify, and it pops up, and it will actually pop up and say, hey, there's like a disk drive, and you can go to the device manager, and it says USB Loofah USB drive, and you can get some details about it, like do not enable write caching, bad idea, because you want to be able to write. You want to write it, and then you can eject it. By default, when you eject it, we'll launch it, and then you can look at the hardware device. I actually will eventually VAD and PID, and I know it's in here, one of these. Display name. I don't know. I'll look at it later, but I'll figure out what it is, and I'll double check it. But yeah, it shows up as a USB device, and so now you want to flash it with firmware. And one of the things you have to watch for is it wants a binary file, not a .hex file. So if we open up the Arduino IDE and we have Blink, the Blink sketch, and have the LED, let's save it, 1 second, and you compile it, it will generate a hex file. blink.ino.hex, and that's what it tries to upload. So you just have to do a little bit of conversion. It's not a really big deal. You want to go to this directory, the temp directory that's created. Eventually I will do this automatically. But go here, and then you can see you have like the hex file, and you do have the E file, but that's not actually used. Although, oh, you know what, this flash, let's pretend it's not there. So you want to create the flash bin. You want to use AVR. Okay, I have to remember what it is. It's AVR object copy, which is, I can never remember where the dashes go. AVR dash obj copy, right. And then you want to do, I just did this, input target hex, output target binary, and then blink.ino hex. Oh, sorry. Hold on, I'm gonna have to Google again. Output. Oh, sorry, you need to do input i.hex and then output flash.bin, and then I have to tell it the type. Maybe we'll just Google this, but I can't, or I will look in my, oh, did I do this here? Oh, wait, here. I have to Google it, hold on. So it was AVR object copy hex to binary. As you can tell, I've had to do this before. Okay, it's ihex. Okay, input is ihex command, Intel hex. Output is, it was right before, it was binary, and then flash.bin. Okay, so that creates for you a flash.binary file, and then you can actually look at the contents of the binary file, and you'll see like there's actually strings in here like server playground. And it's a little bit large for a Blink because it actually creates a USB device as well. So this is the binary file, this is the raw data file, and this is the hex file. So if you look, you know, you see OC94, and this is OC94, and then DE000C94. So you can see that it's the same data, it's just this is in typed out ASCII format, and this is the binary format. To make it easy for the bootloader, you want it to be in binary format. And then, so let's open up circuit play, and then we will drag it over, and you replace it, and then eject, and then it will boot into the circuit playground device. So now if we go to the overhead, you'll see it is blinking once a second. So that's it. And then when we reset, it will actually go straight into the code again. So it won't go into the bootloader. Instead, what I did to make it go into the bootloader, because what we're going to do is much like the Arduino IDE does now, it will connect to this at 1200 baud, and that will actually like kick the bootloader off. Like that's a way for it to force bootloader mode by jumping directly to it. But what I want to do is always have a way to force into the bootloader if like you absolutely have to. So to do that, you hold down the two buttons. I might change this later, but for now I think this is a pretty good technique. And then you hit reset. And then it will come up as the USB device again. So if you want to go to the computer. So now you can see it comes up as the device. And then what you can do is you can actually read the firmware off. So it's that fast. And then when you view this file, you'll see you can actually read, it reads out like this is that code. You can see there's that circuit playground again. And then if you go all the way to the bottom, it actually stops. If you remember, like we had that, the firmware starts at like 6800. At about 6800, that's where the firmware ends, because anything more than that would be the bootloader. So far so good, seems to work. So the next step is actually modifying the Arduino IDE, one, to of course generate the binary file, and then secondly to recognize that it's a hard drive, not a serial device. So when it wants to bootload, it should take a listing of all the disk drives that are loaded up, and then kick off the bootloader, see what new hard drive was added, and then copy the file over and then eject the drive. So I'll probably need to write a little helper application to do that, and I'll probably just do it in Python or something, because Python actually has pretty good OS support, And then for like Macs and Windows and Linux, it'll just do that. And if you are running on something where you don't have access, you can always manually do it by just you load the bootloader manually, or you reset into the bootloader, and then you drag the file over. So I wanted to have like 2 ways of doing it, both automatic and manual. So hopefully this is going to work out. And then we'll do a lot of tests with this, and we'll make sure it works for all the example code, and then we'll launch and see like this. I haven't seen Arduino yet that uses mass storage as a bootloader method, but there's enough benefits that I think it's worth trying.
Okay, you want to take a couple questions?
Yeah, sure. I'll take some questions.
All right.
Mr. Lady Ada?
Yeah, so for Circuit Playground, did you think about other chips that maybe would have some headroom? Why made you choose this chip?
That's a good question. Yeah, I did actually think about a couple other chips. There's a lot of chips that are available. One of the things that I wanted to do was launch quickly, and even though I could get an STM32 for a lot less, there's a huge body of existing code that already works for this chip, and in particular, I really wanted to have mouse and keyboard USB support. And while we could do that and add that to another chip, I wanted to get this done fast enough. Secondarily, we actually have fairly good pricing for this chip from Atmel, and it makes the pricing that they give us is good enough that it made sense to look at it. I'm not paying like retail pricing. Like we have a relationship with Atmel. We buy so many chips from them that we could negotiate a much better price. And even though I'm not expecting this I'm expecting this to be used in many ways, I did want to maintain Arduino compatibility. I think that's powerful. And I've written a ton of code for Arduino. So if I can leverage all that code, it means I can go faster. But we have talked about it like, could we make a version based on the NRF51822? We get Bluetooth Low Energy, or maybe, like a chip like the ESP8266, then you get Wi-Fi. So we are thinking about all these options, but I wanted to launch with something solid and well-known, even though it is a little bit of a tight fit to get all the stuff I wanted to do. But we've, all the test code that we've tried has fit into the size of the flash. Like there's nothing that we're like, oh, if only we had like more RAM or more flash. The stuff we're doing is kind of simplistic. It's meant to be an introduction to programming.
Okay, next up, will you make a bootloader that you can program and use it like a regular serial device?
Well, the thing about the bootloader is it only runs when you want. So what you can do is program it in with firmware that would make it into a serial device. But you only come with one bootloader. I mean, if you can solder wires to the back and reprogram it with any USB T need, you can program in like the Flora bootloader, and the Flora bootloader will work just fine. That's what we were testing with before. But I wanted to go a different direction with this one. So I think we might, maybe if it's really in demand, we'll have 2 versions, one with one bootloader, one with the other. But I'm not sure. I'd like to stick with one.
Okay, and with that, is the Desk of Lady Ada. We'll be here again.
Okay, well, so far so good. We're going to keep hacking, and this, by the way, this may not work out. This is like I've only tried this bootloader like 4 times. Like that was pretty much, this is the 3rd time I've tried it. So we'll see how it goes. I'm willing to change my mind if there's other options, but see you maybe tomorrow for another Desk of Lady Ada.
Okay. Desk of Lady Ada is supported by you, the viewer, if you want to continue seeing fantastic engineering programming live almost all the time. Please pick up an electronics kit, product or more at Adafruit.com. The top place to get things from Adafruit. I'm so glad we don't have ads because I can just say stuff like
You're not even making any sense.
Like you can buy Adafruit stuff at Adafruit.
You can also buy it at DigiKey.
You can buy it from DigiKey, Mauser, Arrow.
And then don't forget later tonight, maybe there'll be a stream from Tony DeCola. So if you want to see,
there might be the desk from Tony D.
There might be Desk of Tony D, and if there is, he's probably going to show his Circuit Playground and the stuff that he's working on. So he's working on user code, and I'm working on bootloader code. Maybe we're going to meet somewhere in the middle.
So pick up a kit so we can keep this up.
Do you know how expensive this oval is? This oval's pricey.
It was an in-app purchase. They don't give away ovals for free.
All right, later, everybody. Ridiculous. Ridiculous.